everyone, I am Vijay Laksshmi. Welcome to my YouTube channel. Here I will teach class 10 mathematics. Today we will learn about real numbers chapter 1. So first we will know about real numbers. What are real numbers? Real numbers are all those numbers that can be represented on a number line. Rational, irrational, both are real numbers, because in class 9th we had learned how to represent irrational numbers on number line. And real numbers, we know how to represent them on number line. So both rational and irrational, they are real numbers. Then prime numbers. Prime numbers, as we know, are those numbers which has only two factors, 1 and the number itself. Example 11, 23, 7, etc. Next, what are composite numbers? The numbers which has more than two factors. Every number other than prime number are composite. Here are some points that need to be remembered while working on these both, prime and composite numbers. First, 1 is neither prime nor composite. 2 is the only even prime number. Then co-prime numbers. What are co-prime numbers? Those numbers which has 1 as their HCF, means there is nothing common between those two numbers, are called co-prime. Our next important topic is fundamental theorem of arithmetic. It says every composite number can be expressed as product of primes, and this expression is unique apart from order in which they appear. We can see in the example, when we factorize 18, we get 2 into 3 into 3. We can write it in the order 3 into 3 into 2. It does not make any change. So, fundamental theorem of arithmetic says composite number can be expressed as product of primes irrespective of the order we represent. Next is application of this theorem. Firstly, we will use it to find HCF and LCM. Secondly, we will use it to prove irrationality of numbers. Next, construction of a factor tree. Factor tree, as we have learned in our earlier classes how to make a factor tree. But we get some questions, like in example you can see incomplete factor tree and you have to find the missing variables. By method of prime factorization, you can find the missing variables, like in the example on the screen you can see. Next, this question is very important. Prove root 2 is irrational. Here you can change the number. In place of root 2, there can be root 3, root 5, root 7. So, how to start with it? Let us assume a contradiction, that root 2 is rational. We will start with assuming that root 2 is rational. So, if it is rational, it can be represented in the form a upon b, where a and b are co-prime. Then we will square both sides and we will get 2b square equal a square. This means a square is divisible by 2 and a is also divisible by 2. So we can write a equal 2c, where c is any integer. Then by replacing value of a in our equation, 2b square equal a square, we will get b square equal 2c square. This again shows that b square is divisible by 2. So b is divisible by 2. A and b have common factor 2. So here comes the contradiction, that a and b are not co-prime, since they have 2 as a common factor in them. Hence our assumption is wrong. Root 2 is irrational. There is one more type of question which you would see. Prove 3 plus 2 root 5 is irrational. It is similar to the previous question, more or less. Here also we have to do the same thing. We will assume first that the given term, whichever we are required to prove irrational, is rational. Then by taking the contradiction, and we will move forward to show that it is, our assumption is wrong and the given term is irrational. Our next type of question is to find HCF and LCM of composite numbers. We'll apply the method of prime factorization and find the primes which form as a product of the given composite number. Then to find HCF, as the name suggests, highest common factor, we will pick all the common factors between the given numbers and find their product, which is our HCF. And for LCM, we will take all the numbers, all the factors which we got in the prime factorization of the given numbers, as you can see in the example, to calculate the LCM. Next very important topic is relation between HCF and LCM. We will use this relation to verify and to find HCF or LCM or the either of number in some of the questions. So the relation is HCF multiplied by LCM gives product of numbers. We will get the questions to verify this relation or to find either of HCF or LCM or any of the number. First, we'll find the product of HCF and LCM for the previous question we did, and then we'll find the product of numbers, and we can see that LHS is equal to RHS. Hence, the relation between HCF and LCM is proved. This is all about the first chapter. In next video, we will practice questions of NCERT and extra questions related to this chapter. Stay tuned. Thank you for watching.